Wire nuts are generally not the best choice for outdoor electrical connections. Their susceptibility to moisture and temperature changes makes them prone to corrosion. When exposed to the elements, wire strands can oxidize, leading to compromised electrical connections and potential failures. For outdoor installations, several alternative techniques offer superior reliability. Firstly, consider heat shrink connectors. These connectors are designed to create a weatherproof seal, effectively protecting the connection from moisture and corrosion. This is achieved by a heat-activated adhesive lining that bonds to the wires, preventing water ingress and ensuring a long-lasting, secure connection. Secondly, Wago connectors are a viable option. These push-in connectors offer a secure connection without the need for twisting or soldering. They are specifically designed for outdoor use and provide a reliable alternative to traditional wire nuts. Their ease of use and secure locking mechanism make them a popular choice for various outdoor applications. Thirdly, soldering the wires together, followed by covering them with heat shrink tubing, is an excellent method for creating a permanent and airtight connection. Soldering provides a strong mechanical and electrical bond, while the heat shrink tubing offers an additional layer of protection against moisture and corrosion. This method is particularly suitable for connections that require long-term reliability and minimal maintenance. If you suspect that your existing wire nut connections have become compromised, replacing them with a more appropriate method is highly recommended. Heat shrink connectors and Wago connectors are both excellent choices for ensuring a reliable and long-lasting outdoor electrical connection. Several additional tips can further enhance the reliability of outdoor electrical connections. Firstly, always use the correct size wire nuts or connectors for the wire gauge you are working with. Using an improperly sized connector can lead to a loose or insecure connection, increasing the risk of failure. Secondly, when using wire nuts, twist the wires together tightly before inserting them into the wire nut. This ensures a good mechanical connection and maximizes the contact area between the wires. Thirdly, applying a layer of electrical tape over the wire nut can provide added insulation and protection against moisture. However, electrical tape alone is not a substitute for a proper weatherproof connector. Fourthly, keep the wires protected from the elements by using a weatherproof enclosure or sealant. This will help to prevent moisture and corrosion from reaching the connection, extending its lifespan. Fifthly, regularly inspect outdoor electrical connections for any signs of corrosion or damage. Early detection of potential problems can prevent more serious issues from developing. The National Electrical Code, or NEC, provides guidance on proper wiring methods and materials for various applications, including outdoor installations. Refer to the NEC for specific requirements and best practices in your area. When selecting a method for connecting wires, consider the following factors. 1. The environment in which the connection will be located. 2. The level of protection required. 3. The ease of installation and maintenance. Heat shrink connectors are ideal for situations where a completely waterproof connection is essential. Wago connectors are a good choice for applications where ease of use and reusability are important. Soldering is suitable for connections that require maximum reliability and are not subject to frequent changes. Regarding wire gauges, here's some guidance. For lighting circuits, 14.2 or 12.2 AWG American wire gauge copper wire is commonly used. For higher amperage circuits, such as those supplying power to appliances or equipment, larger wire gauges like 10.2 or 8.2 AWG may be required. Always consult the NEC and local electrical codes to determine the appropriate wire gauge for your specific application. For voltage drop considerations, the longer the wire run, the greater the voltage drop. To minimize voltage drop, use a larger wire gauge or consider using a higher voltage system. The NEC provides tables and formulas for calculating voltage drop. For example, NEC Table 310.15. The 16 provides ampacity ratings for various wire sizes and insulation types. NEC Section 210.19. A1 provides guidance on conductor sizing for branch circuits. NEC Section 310.15 provides general requirements for conductor ampacity. For example, a 14 AWG copper wire with type THHN insulation has an ampacity of 15 amps at 30 degrees Celsius or 86 degrees Fahrenheit ambient temperature. A 12 AWG copper wire with type THHN insulation has an ampacity of 20 amps at 30 degrees Celsius ambient temperature. A 10 AWG copper wire with type THHN insulation has an ampacity of 30 amps at 30 degrees Celsius ambient temperature. When making electrical connections, it is important to follow proper safety procedures. Firstly, always disconnect the power supply before working on any electrical circuit. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical circuits in wet or damp conditions. Fifthly, if you are not comfortable working with electricity, consult a qualified electrician. For outdoor lighting circuits, ground fault circuit interrupter, or GFCI, protection is typically required. GFCI protection helps to prevent electrical shock by detecting ground faults and interrupting the circuit. GFCI receptacles and circuit breakers are commonly used for outdoor lighting circuits. NEC Section 210.8 provides requirements for GFCI protection in various locations. In addition to GFCI protection, surge protection is also recommended for outdoor electrical circuits. Surge protection helps to protect electronic equipment from damage caused by voltage surges. Surge protective devices, or SPDs, are available for both individual circuits and the entire electrical panel. NEC Section 230.67 provides requirements for surge protection. Regarding specific products, several reputable manufacturers offer high-quality heat shrink connectors, Wago connectors, and soldering equipment. Research different brands and models to find the best products for your needs. Always choose products that are UL listed or have other recognized certifications. In summary, wire nuts are not ideal for outdoor electrical connections due to their susceptibility to moisture and corrosion. Consider using heat shrink connectors, Wago connectors, or soldering to create more reliable and long-lasting connections. Follow proper safety procedures when working with electricity, and consult the NEC and local electrical codes for specific requirements. By implementing these best practices, you can ensure safe and reliable outdoor electrical connections for years to come. When selecting heat shrink connectors, ensure they are rated for outdoor use and are compatible with the wire gauges you are using. Look for connectors that have a built-in sealant to provide a watertight seal. Follow the manufacturer's instructions for proper installation, including the recommended heating temperature and duration. When using Wago connectors, choose models that are specifically designed for outdoor use and are rated for the amperage of the circuit. Ensure the wires are properly stripped and inserted into the connector according to the manufacturer's instructions. When soldering wires, use a Rusin core solderer and a soldering iron with adjustable temperature control. Clean the wires thoroughly before soldering to remove any oxidation or contaminants. Apply heat to the wires and solder until the solder flows smoothly and creates a strong bond. After soldering, allow the connection to cool completely before applying heat shrink tubing. When applying heat shrink tubing, use a heat gun or a heat shrink oven to evenly shrink the tubing around the connection. Avoid using an open flame, as this can damage the insulation and create a fire hazard. Ensure the heat shrink tubing extends beyond the soldered connection to provide complete insulation and protection. When selecting electrical tape, choose a high-quality tape that is rated for outdoor use and is resistant to moisture, UV radiation, and extreme temperatures. Overlap the tape layers to create a secure and waterproof seal. Avoid stretching the tape excessively, as this can reduce its effectiveness. When using a weatherproof enclosure, choose an enclosure that is rated for the environment in which it will be installed. Ensure the enclosure is properly sealed to prevent moisture from entering. Use weatherproof fittings and connectors to maintain the integrity of the enclosure. When applying sealant, choose a sealant that is compatible with the materials being sealed and is rated for outdoor use. Clean the surfaces thoroughly before applying the sealant to ensure a good bond. Apply the sealant evenly and allow it to cure completely before exposing it to moisture. When inspecting outdoor electrical connections, look for signs of corrosion, such as green or white deposits on the wires or connectors. Check for loose connections or damaged insulation. If you find any problems, repair them immediately to prevent further damage or safety hazards. If you are not comfortable performing electrical repairs yourself, consult a qualified electrician. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. Always disconnect the power supply before working on any electrical circuit, and use insulated tools and personal protective equipment. By following these guidelines, you can create safe and reliable outdoor electrical connections that will provide years of trouble-free service. When making a splice or termination, always ensure that the wires are properly prepared. This includes stripping the insulation to the correct length, cleaning the wires to remove any contaminants, and pre-twisting the wires together when using wire nuts. Proper wire preparation is essential for creating a secure and reliable connection. For example, when using wire nuts, strip the insulation back approximately 3/4 inch. Twist the wires together tightly using pliers, then insert them into the wire nut and twist until the connection is secure. For stranded wire, it is often helpful to tin the ends with solder before making the connection. This will help to prevent the strands from fraying and ensure good electrical contact. When using crimp connectors, choose the correct size connector for the wire gauge and use a crimping tool that is designed for that type of connector. Follow the manufacturer's instructions for proper crimping technique. A properly crimped connection should be mechanically strong and electrically sound. When working with aluminum wire, it is important to use connectors and tools that are specifically designed for aluminum wire. Aluminum wire expands and contracts more than copper wire, and it can also corrode more easily. Use an antioxidant compound to prevent corrosion and ensure a good electrical connection. When running wires through walls or ceilings, protect them from damage by using conduit or cable protectors. This will help to prevent the wires from being pinched or cut, which could cause a short circuit or fire hazard. When working with electrical panels, be aware of the potential hazards and take appropriate precautions. Never touch any bare wires or components inside the panel. Use a voltage tester to verify that the power is off before working on any circuit. If you are not comfortable working with electrical panels, consult a qualified electrician. When installing outdoor lighting, choose fixtures that are rated for wet locations and are designed to withstand the elements. Ensure the fixtures are properly grounded to prevent electrical shock. Use weatherproof wiring and connectors to protect the wiring from moisture and corrosion. When installing underground wiring, bury the wires at the proper depth and protect them from damage by using conduit or direct burial cable. Follow the NEC and local electrical codes for specific requirements. When working with high voltage circuits, be extra cautious and take all necessary precautions. High voltage circuits can be extremely dangerous, and even a small mistake can be fatal. If you are not qualified to work with high voltage circuits, consult a qualified electrician. Always double check your work before energizing any circuit. Make sure all connections are tight, all wires are properly insulated, and all safety devices are in place. Energizing a circuit without properly checking your work can be extremely dangerous. If you are unsure about anything, consult a qualified electrician. The electrical industry is constantly evolving, and new technologies and techniques are always being developed. Stay up to date on the latest advancements by attending training courses, reading industry publications, and networking with other professionals. Continuing education is essential for maintaining your skills and knowledge. When troubleshooting electrical problems, start by checking the simplest things first. Make sure the power is on, the circuit breaker is not tripped, and the switch is in the on position. Then use a voltage tester to check for voltage at various points in the circuit. If you find a point where there is no voltage, that is likely where the problem is located. Be systematic and methodical in your troubleshooting approach to avoid wasting time and effort. When replacing electrical components, always use components that are of the same type and rating as the original components. Using incompatible components can cause problems or even create a safety hazard. If you are not sure what type of component to use, consult a qualified electrician or refer to the manufacturer's specifications. When disposing of old electrical components, follow proper disposal procedures to protect the environment. Some components, such as fluorescent lamps and batteries, contain hazardous materials that must be disposed of properly. Check with your local recycling center or waste management company for information on proper disposal methods. When working with electrical equipment, always follow the manufacturer's instructions and safety guidelines. Using equipment improperly can cause damage or injury. If you are not familiar with the equipment, take the time to read the instructions before using it. Remember that electricity is a powerful force and it should be treated with respect. By following proper safety procedures and using good judgment, you can work safely with electricity and avoid accidents. If you ever have any doubts or concerns, consult a qualified electrician.